Hello and welcome to the sessions. Fundamentals of Chemistry for Medicine LO4 carry out simple molar calculations. How do you carry out simple molar calculations? This video explores the fundamentals of chemistry for medicine, focusing on moles and molar mass. Learn the essential calculations needed for accurate results. A mole is a standard unit used to measure the amount of a substance. 1 mole contains Avogadro's number of particles. The molar mass of a substance is the mass of 1 mole, measured in grams per mole. To find molar mass, add the relative atomic masses of all atoms in the formula. For example, the molar mass of sodium chloride is 58.5 grams per mole. The basic formula used is number of moles equals mass divided by molar mass. For example, if you have 117 grams of sodium chloride with a molar mass of 58.5 grams per mole, divide 117 by 58.5 to get 2 moles. This formula is essential for determining the amount of substance. Always ensure units are consistent. Rearrange the formula to calculate mass as moles times molar mass. For example, if you have 0.5 moles of magnesium oxide, with magnesium at 24 and oxygen at 16, the molar mass is 40 grams per mole. Multiply 0.5 by 40 to get 20 grams. This method is crucial for precise mass determination. For compounds, calculate the molar mass first. Take calcium carbonate, for instance, with calcium at 40, carbon at 12, and oxygen at 16 times 3. The molar mass is 100 grams per mole. If you have 25 grams of calcium carbonate, divide by 100 to get 0.25 moles. Accurate molar mass calculation is vital for compound analysis. Balanced chemical equations show the mole ratio between substances. For example, in the reaction 2 magnesium plus oxygen equals 2 magnesium oxide, 2 moles of magnesium react to form 2 moles of magnesium oxide. If you start with 1 mole of magnesium, you will form 1 mole of magnesium oxide. Understanding mole ratios is key in chemical reactions. Always write the chemical formula correctly. Calculate molar mass before performing any division. Use the correct units, grams and moles. Use the balanced equation to find mole ratios. These key points ensure accurate molar calculations. To carry out calculations involving moles and masses, use the relationship between mass, molar mass, and number of moles. The formula is number of moles equals mass divided by molar mass. Alternatively, mass equals number of moles times molar mass. This relationship is foundational for chemistry calculations. Ensure all measurements are precise. Calculate the number of moles in 46 grams of sodium with a relative atomic mass of 23 grams per mole. Divide 46 by 23 to get 2 moles. This example highlights the importance of accurate calculations. Always double-check your work for precision. Calculate the mass of 0.25 moles of magnesium with a relative atomic mass of 24 grams per mole. Multiply 0.25 by 24 to get 6 grams. This example demonstrates the practical application of the formula. Consistent units are crucial for accurate results. Calculate the number of moles in 90 grams of water. Hydrogen is 1 times 2 equals 2, and oxygen is 16. The molar mass of water is 18 grams per mole. Divide 90 by 18 to get 5 moles. Accurate molar mass is essential for compound calculations. Calculate the mass of 1.5 moles of carbon dioxide. Carbon is 12, and oxygen is 16 times 2 equals 32. The molar mass of carbon dioxide is 44 grams per mole. Multiply 1.5 by 44 to get 66 grams. This demonstrates the importance of precise molar mass. Always calculate molar mass first. Ensure units are correct, grams and moles. The same formula applies to elements and compounds. Round answers sensibly where required. These points ensure accurate and reliable results. The concentration of a solution tells how much solute is dissolved in a given volume. Concentration is usually measured in grams per cubic decimeter or moles per cubic decimeter. This measurement is crucial for understanding solution properties. Accurate concentration calculations are essential in chemistry. Always ensure units are consistent. Use the formula. Concentration equals mass of solute divided by volume of solution. For example, dissolve 10 grams of sodium chloride in 0.5 cubic decimeters of water. Divide 10 by 0.5 to get 20 grams per cubic decimeter. This calculation is vital for solution analysis. Consistent units ensure accurate results. Rearrange the formula. Mass equals concentration times volume. For example, calculate the mass of solute in 0.25 cubic decimeters of a solution with a concentration of 40 grams per cubic decimeter. Multiply 40 by 0.25 to get 10 grams. This method ensures precise mass determination. Accurate measurements are key. When concentration is given in moles, use the formula. Concentration equals number of moles divided by volume. For example, calculate the concentration of a solution containing 0.2 moles of potassium nitrate in 0.4 cubic decimeters. Divide 0.2 by 0.4 to get 0.5 moles per cubic decimeter. This calculation is crucial for solution properties. Ensure all units are consistent. Use the formula. Number of moles equals concentration times volume. For example, calculate the number of moles in 0.1 cubic decimeters of a 2.0 moles per cubic decimeter solution. Multiply 2.0 by 0.1 to get 0.2 moles. This calculation is essential for determining substance amount. Accurate volume conversion is key. Always convert volumes into cubic decimeters before calculating. 1 cubic decimeter equals 1,000 cubic centimeters. Volume in cubic decimeters equals volume in cubic centimeters divided by 1,000. For example, 250 cubic centimeters is 0.25 cubic decimeters. Accurate volume conversion is crucial for precise calculations. For further reading, refer to the ebooks and journals on the Moodle for this unit. Additional resources include Chemistry, The Molecular Nature of Matter and Change by Silberberg and Ametes. Chemistry, A Molecular Approach by Tro is also recommended. These references provide in-depth knowledge. Ensure to consult these for comprehensive understanding. Refer to the ebooks and journals for additional resources. For queries, email learnerwork@ukvarsity.co.uk. Submit assignments to the same email. Assignment submission is due 2 weeks after unit completion. Ensure all submissions are on time. In conclusion, carrying out simple molar calculations is essential for understanding quantities and relationships in chemical reactions. Molar calculations allow chemists and healthcare professionals to measure substances accurately, determine concentrations, and prepare solutions correctly. This skill is particularly important in medicine, where precise calculations are required for drug formulation, dosage preparation, and laboratory analysis. Understanding molar calculations supports accuracy, safety, and effective practice in medical and scientific settings. Thank you for watching this video. If you have any questions, please feel free to contact us via email or WhatsApp at 0748 4361 688.